1 goes to 2, 2 goes to 4, 4 goes to 1. Okay, well that's your cycle. So this 1 to 2, 2 to 4, 4 to 1, you can write in this form. Okay. Now this whole permuter, so the 3's didn't change, the 5's didn't change, the 6 didn't change. Now you look at this permutation and you're told it's a member of S6. So this alone, when you know that this is a full member, it's a member of your symmetric group, okay? The fact that 3, 5 and 6 do not appear in this cycle, you interpret that to mean that they map to themselves. So 3 goes to 3, 5 to 5, 6 to 6. Okay? So 3, 5 and 6 are not mentioned, so they map to the same value. So 3, 3, 5 to 5, 6 to 6. Now, a permutation like this may have more than one cycle. You can have the same permutation with 2 or more cycles. That can happen. Alright, so let's say you're told that this cycle belongs to the group. So S6. So let's write this out in the full format, in the full bracket format. How to do it? Well, now it's just one line here with brackets, so we interpret that to be a cycle, right? Now this is a permutation and this is a cycle. They're not necessarily the same thing. Remember that, that's important. Cycles can be a full permutation, but often they're just like one of 2 or more cycles that are part of your permutation. So let's translate this into a full permutation. So 1 goes to 2, okay, 2 goes to 4, and 4 goes to 1. Right? Now 3, 5 and 6 are not mentioned, but you're told that this this cycle here is a permutation, so that therefore the ones that are missing, the numbers that are missing here, they just map to themselves, they don't change. So 3 will go to 3, 5 will go to 5, 6 will go to 6. Okay? So that's how you rewrite this in terms of your bracket notation. Now, now you can start talking in terms, you're going to, in a sense, multiply cycles. What does that mean? How do you do that? Well, let's say this cycle you're given, so just one line, okay, and you're told it's also a member of S6, the symmetric group with 6 objects. Now look, 3 and 4 are not mentioned in this cycle. So, but you're told that that cycle is a full representation. It's one of the members of this. You're given that, told that here. Okay, so that means that 3 and 4 map to themselves. Now you can write this out in a similar way as you did here. Okay. Now we've already got that. Here it is here. Now you can write that out in this format, in the full bracket format. This. So we now have this permutation and this permutation. So this one belongs to S6. This also belongs to S6. S6 is a group, and therefore closed, and therefore this times this will do this permutation, then followed by this other one, permutation. The result is a permutation. It's because of closure. Right? This is a group, therefore it's closed. Now, interestingly, if you expand this in its full form, as here, you do the same for this. I haven't written it up here. Do that as an exercise, and then multiply those 2 permutations. Get an answer. Now, here you've commuted these. You've swapped the order. So expand this out, as here. Expand that out, whatever it is that you get, and then multiply those 2 permutations, one after the other. The answer that you'll get will be different, usually, from what you got here. In other words, this cycle and this cycle does not commute, right? Because this times this is not the same as when you swap these two around, right? So that is not the blig times blog is not the same thing as blog times blig, right? Now, if you do a similar test, so you're told that these two cycles are permutations belonging to S6, right? Now, so you expand that out, you know, in this form in terms of the bracket notation, and you multiply the two, get an answer. And now, if you swap these around, if you commute them, if you commute these two cycles, you know, you get this. And so expand it out, multiply the two, look at the result, and see if it's the same as this. And the answer will be yes. And why is that? Well, because this cycle and this cycle share no common value, no common integer, right? So one does not, there's no 1 here, there's no 4 here. Now when that's the case, these two cycles, by definition, are said to be disjoint, right? So two cycles are disjoint if they have no common member. Now have a look at these two. They have 1 and 2 in common, right? They both have 1 and 2. But here, this one has no 1 or 4, right? And this one has no 2, 3 or 5. Okay? So this cycle and this cycle are disjoint. Okay? Now disjoint cycles do commute. So you can, you know, the answer you get from these two will be the same as you get when you multiply two cycles that way, right? And the reason they commute is this is operating on a completely different, disconnected subset from what this is operating on, right? See, the 2 will change to 3, the 3 will change to 5, the 5 will change to 2, and that cycle has no effect on the other numbers, different from 2, 3 and 5. And a similar argument here. So the effect of that is independent of the effect that this has, and it's that independence that creates the commutivity that affects you, that these two cycles commute. Okay, look, I've run out of board, so I'll stop here. So usually a session, by session I mean like one whiteboard's worth of material. Okay, and typically it's around, I don't know, 30-40 minutes, so that's one session, which I then cut up into clips of about, I have 3 or 4 clips per session. That seems to be fairly typical. So when I come back, I can continue on talking about, well, in fact, now that you're familiar with the notion of a disjoint cycle, I can show you a way how to rewrite a full permutation in terms of products of cycles, of disjoint cycles. And we'll do some exercises a bit with that notion, taking you know, any old permutation, and then we can break it up into smaller cycles, and those cycles are disjoint, and that's very useful.